Welcome to another session of 4AC work example. Today we look at example 3.7. For the circuit given below, we want to use the current divider rule to calculate the branch current I1 and I2. Secondly, we want to verify that the calculated answers complies to Kirchhoff's current law. We'll start by writing down the values that has been provided. Circuit current IS 50 amps with an angle of 30 degrees. The branch circuit I1, branch circuit I2. Resistance R is 3 ohm and the impedance the reactance, inductive reactance is 4 ohm and the capacitive reactance is 8 ohms. Right? So the first thing we should do is to calculate the branch impedances. So branch impedances number 1 Z1 is equals to R plus JXL, which is 3 plus J4 ohms in rectangular format, or in the polar format we can present it as 5 at the angle of 53.13 degrees. Similarly, the branch impedance Z2 can be computed as minus JXC, since it's only a capacitor there, and that's equals to minus J8, or similarly I can write it as 8 at the angle of minus 90 degrees. Right. Now the current divider rules works as follows. The branch current I1 can be calculated as Z1 divided by Z1 plus Z2 multiplied by IS. That means I can substitute in 5. This should be I2. So if I substitute in the values, I will get 8, the angle of minus 90 degrees, multiplied by the current, which is 50 amps, angle of 30 degrees, divided by Z1 plus Z2. Z1 plus Z2, since it is the addition of two complex numbers, I will use the rectangular format as minus J8. That gives me 8 times 50 is 400 at the angle of minus 90 plus 60, that's minus 60 degrees. Divide by the bottom, I have 3 minus J8. J4. Okay, so that gives me 400 at the angle of minus 60 degrees divided by 3 minus J4 is just 5 at the angle of minus 53.13 degrees. That gives me 80 at the angle of minus 60 minus minus 53.13, and that is minus 6.7. Okay, that's the branch current one. Now for branch current 2, similarly I can use the current divider rule. Current divider rule means that I2 is equals to Z1 over Z1 plus Z2 multiplied by I. Z1 is 5 at an angle of 53.13 degree multiplied by the current, which is 50 at an angle of 30 degrees, divided by the same factor we had before, right? Exactly the same. So in this case, I will just write straight as 5 at an angle of minus 53.13 degrees. This gives me 5 times 50, 250 divided by 5. And the angle is 53.13 plus 30, that's 83. Minus this value. So it's this plus this minus this. So it's actually the three of them add up. That gives me 136.26 degree in ampere. That's 50 at an angle of 136.26 degree in ampere. Alright, so I have I1 80 angle of minus 6.87 degree, and I have I2 50 at the angle of 136.26 degree. Okay, that is part 1. Now part 2 wants me to verify whether this is in accordance to Kirchhoff's current law. Now, part 2, Kirchhoff's current law states that the total current IS must be equal to the branch current. So in this case, I need to show whether this is correct. First of all, let's look at I1 plus I2. Now, from the earlier calculation, I1 is 80 at an angle of minus 6.87 degree ampere, plus I2, which is 50 at an angle of 136.26 degree in ampere. Convert them into rectangular form in order for them, so that I can add the two numbers up. So to convert them to rectangular form, (80) angle 6.87 will convert into 79.4 minus J 9.57 plus 50 angle 136.26 translate into minus 36.12 plus J 34.57. Right? The real number can add up. Will give me 43.28, and minus add for the imaginary number gives me J 25. Convert this rectangular format into polar form. It gives me 50 at an angle of 30 degrees. And this value is exactly the same as IS. Hence, the results are in agreement with Kirchhoff's current law. Well, that's all for this question. I hope you learned something. Thanks for watching.